Hi friends, in this video I would like to explain how do you test an hypothesis for difference between two standard deviations. Let us see. For that, see here difference between the two standard deviations. That's why we need to know what are the two samples, for that from where you are collecting those two samples. Let us take two populations A and B with standard deviations sigma 1 and sigma 2, and from these two populations, if we take the two samples, those sizes n1 and n2 respectively, and the standard deviations are represented by s1 and s2 respectively. These can be drawn from the populations A and B, but see here we have to test certain statement. It is nothing but null hypothesis h naught, either sigma 1 is equal to sigma 2 or less than or equal to or greater than or equal to. And as we know that there is some standard error for different sampling distributions, and for these sampling distributions, here what is the sampling distribution? The sampling distribution of difference between the two standard deviations. What is the standard error for that? Suppose the sampling distribution of a single standard deviation, yes, for large sample it is nothing but sigma square by 2n, and for these standard deviations, once you find sampling distribution and find the standard deviations for that, you will, by compared to the standard deviation of population, you will get the error. It is 1 by 2n. So that's why this we can call it as standard error. But for see what is variance for that. Standard error of standard deviation. This is for the variance, and see the same way for the standard deviation sigma by root n. This is for single standard deviation. If suppose there are two standard deviations, its difference is, suppose we will take sigma 1 minus sigma 2, sorry, this is for the population. For samples we need to take S1 minus S2. For these S1 minus S2, you take the sampling distribution, and for that sampling distribution find the standard deviation. You will get the error, standard error of sigma 1 minus sigma 2. See what you may get, square root of S1 square by N1 plus S2 square by N2, where S1 and S2 are standard deviations of the samples S1 and 2, N1 and N2 are the size of the samples 1 and 2 respectively. And see, suppose for these type of sampling distributions, if suppose any problem related to this, how do you test an hypothesis? And for that we can choose the null hypothesis and alternate hypothesis, or suppose it is greater than or equal to less than, and this is less than or equal to greater than. And accordingly the test statistics, because of it is a large sample, we are going to take a standard normal distribution and corresponding variable z, difference of the two standard deviations of the samples minus difference of the two standard deviations of the population by standard error. This is square root of S1 square by 2n1 plus S2 square by 2n2. But how do you test? The same thing for certain examples. Let us take one example. The mean yield of two sets of plots and their variability are as given below. Examine whether the difference in the variability in yields is significant. If suppose this is the first set and this is the second set, first set size 40, second set size is 60. For that mean 1258, for the second set mean 1243, standard deviation of the first set 34, standard deviation of the second set 28. Suppose I represented by S2, this is S1, it is X1 bar, this is X2 bar, this is N1 and this is L2. I think this data is not required, maybe it is given extra, whether if you would like to, is if it is necessary we can use it, otherwise no need. So here we need what is N1, what is N2, what is S1 and what is the S2, and for these what is the null hypothesis. It is in between sigma 1 and sigma 2 is right, what the statement given in the problem, whether the difference in the variability in yields is a significant. Is there any difference or not? It's nothing but minus, suppose I'll take 0, or you will take sigma 1 is equal to sigma 2. So then what is the corresponding alternate hypothesis? Sigma 1 is not equal to sigma 2. So here also level of significance is not given, and let us take suppose 5%, it's nothing but 0.05. See here what those h naught sigma 1 is equal to sigma 2. There is no significant difference in the variability and the yields between the two different sets of plots. Accordingly, the alternate hypothesis sigma 1 is not equal to sigma 2. So it's nothing but h1, it's giving no significant, h naught giving no significant, h1 is giving a significant difference. See, what is the level of significance? We are assuming the 5%, 0.05, the critical region, because here alternate hypothesis not equal to, we have to take the two-tailed test. So two-tailed test is nothing but in both sides of the there is some error. So then what is the acceptable of h naught? Minus z alpha to z alpha. And for this what you will get? Area of z alpha is equal minus y alpha by 2, because it is two-tailed test. And see here what you will get? Mod z less than z alpha, the corresponding z alpha value you will get 1.96. These you will get from z distribution table values. So we have chosen what is a null hypothesis, alternate hypothesis. These we have assumed, and accordingly alternate hypothesis and level of significance, we use the two-tailed test. Then we got what is the acceptable region? Minus 1.96 to positive 1.96 is the acceptable region of h naught. Now for this problem regarding the samples, if you find the test statistics, what is the z value for, suppose this is the random variable s1 minus s2 minus sigma 1 minus sigma 2 by root over s1 square by 2n1 plus s2 square by 2n2. Simply substituting these values from the data here, no need to calculate separate, everything is given in the problem itself. That's why simply substituting. Observe here h naught we are taking sigma 1 minus sigma 2. So that's why its value is 0 by default. By calculating this fraction, we are getting 1.3098. It should be here. And it lies in acceptable region because less than 1.96. So therefore, see here, h naught will be accepted. So that means there is no significant difference between the two different sets. There is no variation. So this is, friends, how do you test of hypothesis for difference between the two standard deviations. So in this video you came to know that what is the standard error, how do you test an hypothesis for difference between the two standard deviations. Thank you.